Hi, in this Lightboard session we're going to talk about API policy enforcement using a proxy. Now, API policy enforcement is what you would call runtime governance, where you are controlling access to a downstream implementation. So in our terms, we have a proxy, which is going to be the point of enforcement. So this is what the clients will be talking to. So as far as the API client, now this would probably be an application rather than a person involved. And somewhere downstream is an implementation. Now, if you've got a standalone proxy, this implementation could be anything. It could be a Mule application, could be some other technology that you're wanting to apply policies. Now, policies are for those quality of service, security, various cross-cutting concerns. So they're a little bit like aspects, if you know about aspect-oriented programming. Now, with the downstream implementation, the proxy has to have some configuration that knows how to talk to that downstream implementation. And that configuration is done through API Manager, which is part of the control plane. So API Manager, you create what we call an API instance, and then that is something that you can then apply policies to. So at the point when you create an API instance, it ends up with an ID. Now that ID is so that you can keep a track of what policies have been put on that API instance. Now, how does this work at runtime? Well, when you start up the Mule application server, so the Mule runtime fires up that is running your proxy, and the underlying mechanism reaches out and gets a list of, it says, get policies. So it says get the current list of policies so that it can keep it in a local cache. So essentially on disk, you've got a list of policies. And from that point onwards, it doesn't need to make calls out. So at runtime, when an execution request comes in, so an HTTP request or an HTTPS request comes in, it's talking locally to a local cached version of the policy code and configuration that you've applied. So the policy enforcement point doesn't need to make a call out to the control plane. And that's an important point, because if for whatever reason there is a connectivity issue with the control plane, you still have the ability to execute that code and pass it on to the downstream implementation. So that's policy enforcement points with a proxy. Now, when you want to use Mule as the implementation, you have an option where you can essentially smush together proxy capabilities and implementation together. It's a thing called auto discovery, and because you've got Mule acting as both API gateway capability and integration capability, so implementation, you can smush those together and it will apply the policies in the same fashion before executing the code that you want to protect. So that's an advantage of having Mule as both implementation and proxy smushed together using auto discovery. Let's talk about how updates to policies take effect. So someone is going to come in and want to change policies or update those policy settings. So you're either going to update or apply new policies. And those changes need to find their way down to the policy enforcement point, which in this case is our proxy. Now, the mechanism for getting the initial list of policies, it kicks off at startup. So when it's up and running, however, there is a essentially scheduled task that periodically comes back and does that same request to get a list of policies. Now, there's a couple of special features at startup that protect and it can take place at runtime, and it's called gatekeeper feature. So gatekeeper feature will protect your downstream implementation from having requests passed across until it knows it's got a list of the current policies. Now, it has different levels of safety, and there's pros and cons to these. So the idea is that you're going to block traffic until you know you've got the current list of policies. Now, this task is kicking over every 60 seconds or thereabouts, and it at startup checks to get the policies. Now, if it cannot connect to API Manager out in the control plane, then that's when gatekeeper feature is useful, because it'll say, okay, I can't connect, I don't want to risk it, I will block traffic. So as far as the requests coming in, they will be getting back a service unavailable. So that's Gatekeeper feature and how the process of updating policies works.